we're going to talk about compilers, the piece of software which was responsible for translating your program from a programming language into the native language of the computer. So we have different types of languages. We speak human languages, and programming languages are a subset of the human languages. Within the programming languages themselves, the lowest level of language is the machine language, and this is the actual language, the binary language used by the CPU itself. Typically, we program in higher level languages above the machine level language, or the level of machine language. We have different generations of languages. The very first generation was machine language, and people started out programming in the language of the CPU itself, but that was very difficult, very time-consuming. So the next level of language was assembly language, and it was very similar to machine language, but it had some things that made it a little bit faster, and it was readable by humans, which means that you didn't have to write it in binary anymore. You could now write short little abbreviations for the commands, and it would translate them into the binary. The third generation abstracted it a little more and let us program not in one statement for every little instruction on the CPU, but now we could lay out entire expressions as mathematical formula and have them evaluated without having to worry about what had to be loaded into the CPU, what low-level operations had to be done. That is where the C level of languages reside. In fact, most of the languages in use today are third-generation languages. Fourth-generation languages are the type where you show them what you want done, and they figure out exactly how to do it. In common use today, things like SQL are examples of fourth-generation languages. Then we come to the fifth-generation languages, which are just starting to emerge. Most of these are artificial intelligence languages, and the neural networks, the things which run self-driving cars, are examples of these. So let's look at the features of C. C has an English-like syntax. You might not think it when you first see it, but it is relatively like English. It's got a small number of keywords, which means it's a relatively easy language to learn. It is the lowest of the high-level languages, and it's faster than many other high-level languages. It has a large installed base, which means that it's quite popular and it'll be easy to find jobs working in it. It's used in high-performance computing because it is quite a high-performance language, and it is the language that was used to write both Unix, Linux, and a lot of Windows. And they were written in both a combination of C and C++. So let's take a little look at the performance of C. And here's the standard benchmark. And you see that assembler takes 0.18 seconds, C takes 2.7 seconds, and BASIC takes 10 seconds. So C is a lot faster than BASIC, which is a representative of other high-level languages. Assembler still beats it because a human carefully handcrafting assembler can still beat most compilers, but it takes quite a talented, good assembler programmer to be able to beat a modern compiler. So let's take a look at the entire process of compilation. You start out with source code over here, and that's what your program is written in. You run that through your compiler, and that takes your source code and changes it into the binary code of the machine language itself. And that's the end of the compilation process. If you want to execute the program, and you have to come down here and run it. So the same binary code that you compiled is now starting to execute. It takes input from the user, does whatever it does to transform that input, and produces output, which is also shown to the user. Finally, we'll want to take a look at the basic syntax of a language like C. And we start out with a comment, and you can see it's a comment because it's got these slash star and star slash around it. And that indicates that it's a comment. Now, this kind of comment is, you can spread it over multiple lines as long as it starts with slash star and ends with star slash. Okay. Now, comments are completely ignored by the compiler. They're there for humans to read. The other kind of comment we have is the one that starts with slash slash. And those ones go from a slash slash to the end of a line, but they can't go over more than one line. So this is actually the first line in the program here, and it's an include statement which brings in a library, which is a set of pre-written functions, and this is the one for standard input-output, and this gives you your printf and scanf statements for reading and printing, and we'll be talking about those for a great amount of time in the rest of the course. Then we come to main, which is our very first function, and it's actually a very important function because main is the entry point of the application. The entry point is where the computer first starts to execute. And when a computer is handed your application to run, it looks for a function called main to start with. Now, functions have a name. They've got a return type, and this is going to return a type int, which is short for integer. And they've got a parameter list, and this one is void, which means absolutely nothing is in there. Then we have the body of the function, which is a series of statements which are going to be executed one after another in order to execute the function. The body of the function is delimited by these curly braces. So that marks the beginning and ending the body. Within there, we've got two statements. The first statement is a printf, which is going to print a string to the output. In most cases, the output is going to be your computer screen. And the string is delimited with double quotes. And that's not two single quotes, but it's a special character on your keyboard, a double quote. There's a string inside, and it says hello world, followed by a \n. The \n is a special code that says print a new line. You can't type a new line because if you hit enter, it goes to the next line. But you don't want a new line there. You want it all in one line, and you want to tell it to print a new line. So we use \n to tell it to print a new line. Okay, that's all our program is going to do. So what we have to do now is, because we said this function returns an int up top, we now have to return an integer down here, and we return the value 0. All the operating systems agreed that if a program returns 0, it means everything worked. If it returns any other number, it means the program failed in some way. So that's going to return that 0 back to the operating system that invoked main, and that will tell the operating system that our program worked correctly. Last thing we have is the closing curly bracket that terminates the body, and that is all we have to make a very, very simple little C program. So that's my presentation on compilers. Thanks for listening.